Compressible Flow, tutorial number 20. An explosion occurs just above the surface of the Earth, producing a shock wave that travels radially outward. At a given location, it has a Mach number of 2.0. Determine the pressure just behind the shock wave and the induced velocity. We could use T1 equal to 15 degrees Celsius and P1 equal 101 kilopascal absolute. From the question, we know that Mach number before the shock wave is equal to 2. By using this Mach number and this equation, we could calculate the ratio between P2 over P1. P2 here is the pressure after the shock wave and P1 here is the pressure before the shock wave. From the calculation here, we could get 4.5. We could use K equal 1.4 because our medium is an air. After we get the ratio of P2 over P1 equal 4.5, we could calculate the value of P2 by multiply 4.5 times 101 kilopascal, and we could get P2 as 454.5 kilopascal absolute. To calculate velocity before the shock wave, we could use the equation for Mach number as this one. We could rearrange this equation and becomes V1 equal M1 third KRT1. We substitute all the parameters here. We could get that velocity before the shock wave is equal to 680.3 meter per second. To calculate Mach number 2, we could start by using this equation. We substitute all the values. We could get that Mach number 2 square is equal to 0.3333. Then we could calculate the Mach number 2 as 0.5774. To calculate the temperature after the shock wave, we could start by using this equation, the ratio of T2 over T1 for the shock wave equation. We use K is equal 1.4. We substitute the value of Mach number 1, and then we could get the ratio T2 over T1 is 1.6875. To get temperature after the shock wave, we multiply 1.6875 with the temperature before the shock wave, which is 288 Kelvin, to get the value of T2 temperature after the shock wave as 486 Kelvin. Then we could calculate the velocity after the shock wave by using this equation. Then we could get it is 255.2 meter per second. To calculate the induced velocity, we need to subtract V1 minus V2 to get 425.1 meter per second.